There we go. Less. So hopefully you were reading them as you were writing them. Okay, when I call on you, I want you to write the specific, or read the specific number. Jack, read number 1. If. Read 1, statement 1.
Both pairs of opposite sides of
Quadrilateral.
Quadrilateral congruent, then quad
Is a.
is a.
What was that symbolic notation? Only for parallelogram. Okay? All right, Abby, let's read number 2. Statement number 2.
If both pairs of opposite sides of a quadrilateral is parallel, then the quadrilateral is a parallel.
It's like a tongue twister, right? All right, David, number 3. Go slow.
If one pair of opposite sides of a quadrilateral is congruent and parallel, the quadrilateral is a parallelogram.
Okay? Shayna, let's read number 4.
Both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram.
Good. Jet, number 5.
If one angle of quadrilateral supplement to both
Consecutive.
consecutive angles, then quadrilateral is parallel.
And then Chase, my last one.
What is the second word? Is that
Diagonals.
Oh, diagonals.
Mhm.
Diagonals of the quadrilateral bisect each other, then it's a quadrilateral.
Is a parallelogram.
Oh.
Okay? So, we already know the statement from the previous ones, so let's apply them. On example number 1, it's going to ask us, is this true? If it is, which number satisfies? So let's look at the first one. We have 73, and we know our adjacent sides or angles are what to each other? Supplement. Which statement is creating that one? Statement 1, 2, 3, 4, 5, or 6? Statement number 5. So we know this one is a yes. For B, I only have one pair of angles that are congruent. Only one pair. Does that satisfy any of the conditions? Didn't it say both pairs of the angles? So this one is a no. And I know we didn't cover this topic, but this is actually going to create a kite. And if you're like, well, we're not there yet, you don't have to write the kite. For part C, So we know we have two angles are congruent, and then the other as well. Now, just by looking at this, let's kind of think about what we know from the given. What can I say about the two triangles? They are by angle, angle, side. Is that right? Then I know all the corresponding parts are congruent. So I know these two are congruent too. And these two are congruent too. So it's going to satisfy statement number one. Statement number one says both pairs of opposite sides are congruent. Is that true? So statement number one. So for sure it is yes. Does anybody see another statement that could be possible? Statement number three. Three says one pair. Only one pair. That's not going to work. Statement number four. If you read number four, it says both pairs of opposite angles are congruent. That's going to work out because I know by CP/CTC, this has to be congruent to that. So if these two are congruent, these two are also congruent, so it could be also four. But in my opinion, I think the statement number one might be more obvious. What about D? Can that form a parallelogram? No. It's actually a kite again. And this figure is not drawn to scale. You don't have to draw the next image if you don't want to, since we didn't cover kite yet. So kite actually looks like this. And it's got the adjacent sides that are congruent to. And that is not a parallelogram. So let's do our proof on the bottom. I have to write very, very small. Let's write the given. It says PQTS. PQTS is a rhombus with diagonal PR. That's by the given. So if I know we have a rhombus, all the properties of the rhombus will be true. So in this case, let's figure out which two triangles that we're looking at. It could be the top or the bottom, the one on the right on the top or the bottom, or the whole thing on the top or the bottom. Which one do you think it might be? Is it the big one or the smaller ones?
Smaller.
Smaller one? So let's analyze. Here's RQ. I want you to highlight RQ. And then here we have RS. That is my final goal. If that is my final goal, and I want to use everything about the rhombus, I would then need to go ahead and look at the big triangle on the top and the big triangle on the bottom. Do you guys see the notation on PQ is already congruent to PS? For me to include that in QR, I have to use PQR and PSR. So let's see what I know. What can I say that PT is doing to this angle right here? It is bisecting. So let's go ahead and put these two are congruent too. So let's say we have PT bisects the angle QPS. And for this one, we have to write our if-then statement. Someone is not paying attention. Two people in the corner, pay attention, please. If a quad is a rhombus, then the diagonals bisect the opposite angles. If a quadrilateral is a rhombus, then the diagonals bisect the opposite angles. If you want to phrase that in a similar way, that's perfectly fine. So I know the two angles are congruent to angle QPT. Could I also say angle QPR if I wanted? QPT is the same thing as QPR, is that right? What do you guys want, T or R? Okay, I'll stop at T then. QPT is congruent to angle, then I have to go SP what? To T. And if you go to R, that's fine. It means the same thing. That's by definition of angle bisector. This piece is not new. Could I also mention these two that's the obvious statement? It's already on there. So let's put on this here. I have an angle. I have a side. So here I have PQ is congruent to PS. And this one is if-then statement. If a quad is a rhombus, Then what can I say about all the sides? Then all sides are what to each other? They are congruent. Bless you. What do y'all remember about PR being congruent to itself? What was that called? PR is congruent to itself. What's what property? Good, reflexive. If you look in the mirror, it should be you, hopefully. Property of congruence. And that will be another side. So now I know the two triangles are congruent. And I'm going to say triangle PQR is congruent to triangle PSR by side angle side congruence. And our final goal is RQ is congruent to RS. And y'all remember what statement was after two triangles are congruent? Good. Corresponding parts of congruent triangles are congruent. Can I give it to you after? Yeah, after I record. Okay. All right. The theorem number I don't really care about. So I want you guys to name something real quick. If I give you a parallelogram, and we're going to motion like last time, with one right angle. Okay, hands up, give me a parallelogram. If I tell you this parallelogram has to have one right angle, it's going to look like this, right? What shape is that making then? Ooh, a rectangle. For the square, I need to go ahead and kind of reduce it. So we have a rectangle. Put a star next to this one, whatever that means. Now let's look at another parallelogram with congruent diagonals. So parallelogram does not have congruent diagonals, but if I make the diagonal to be congruent, what shape is that going to force to become? Another rectangle. Okay, I'm going to skip all the way to example number 5 on the next page. So on the next page, on example number 5, Reese, will you read the instructions for me?
Which quadrilaterals have property of...
All right. Notice it says quadrilateral with the S in parentheses, right? That means all the possibilities. All possibilities. I hope I spelled that correctly. So I'm going to model the first one. So all sides are congruent. Does square have all sides congruent? Rhombus have all sides congruent? Rectangle? No. Parallelogram? No. So just envision the figure and go, is it? If the answer is no, don't add on to it. So here I have A and B. Okay, with the partner, let's go ahead and finish. And I'll reveal the answer when you're done.
Is that like Is it for threes? Oh.
The I for Mr. Oil.
No, his name is Mr. Owen.
Oh, no, I
Maybe they wanted to be on.
30 seconds.
Angle, it's like angle around this isn't equal angle. This one is adjacent.
Yeah, I would think that, I mean, it's like a lateral, I'm like, oh, it would be a rectangle parallel, that, like, triangular also, so it's just like. Also, so, did you remember when we just talked about yesterday, we said that, like, I could pick a snap or something? I was like, and so she was like,
You only go to the Monday.
Get airheads and street.
yeah, I don't think,
Well, you know, whenever.
Let's check. Put a star on number 5. Next to number 5, put a star next to it. And I want you to underline the key terms. Equiangular and equilateral is referring to a regular polygon. When something is equiangular and equilateral, it is a regular polygon. And if you're ready to move on, give me a thumbs up. I'm ready, are you? Some? Half? All right, so on the back. It says to prove it, but we're not really going to. We're just gonna see if it is possible. So let's notate what is given. How many items are given on example number 6? 2 things. So let's notate. EF is congruent to FG. And then it says EG is perpendicular to FH. So just by looking at this, could we say it is a rhombus? What is missing about the rhombus? That all sides must be? Was that mentioned? So we know this one is going to be no. And let's reason. Only if all sides are congruent. And right now it's only stating the adjacent piece are congruent, and that's it. The next piece you do not have to write. This is actually representing a kite. A kite has 2 adjacent pieces that are congruent. And I know we didn't cover it. That's why I'm telling you, you don't have to write this down. It's perpendicular. So it's actually representing a kite. So if you're a visual learner, you might be able to see it. If not, that's okay. All right, for number 8, how many things are given to us? 4, how nice. So EB is congruent to BG. Are we good with that notation?
Yeah.
Second one says FB is congruent to BH. Good on the second given? Third one now says, well, EG, the whole diagonal, is congruent to FH. So what can I actually say about the 4 individual parts? Ooh, if I know the diagonals are congruent, they should also be congruent too. So I'm just gonna add on 2 tick marks all the way around. And then we have triangle EBF. So EBF, this triangle is the same one as EBH. So if these 2 triangles are congruent, and I know these 2 angles are congruent, then I know the angle must be. So if I know it's got to be congruent, how many degrees? The whole thing is 180, right? And they both share even amount. 90. So now given the statement, could I say, hey, I see a square now? Yeah, square has perpendicular diagonals and congruent diagonals. So yes. I want to mention something that could be possibly a most missed on a quiz or a test. Put a star on this one. So hopefully you'll go back and study your notes. Okay. What symbolic notation am I allowed to use instead of writing out parallelogram? Drawing it. So here's my parallelogram. Can I use that symbolic notation for a rhombus?
yes.
Never. Only the parallelogram can take that. So here I have a rhombus. Okay, do your best to draw a rhombus versus a parallelogram. Mine is probably not going to be perfect, and that's perfectly fine. here's my parallelogram, and here's my rhombus to the best of my ability. And I want to talk about the diagonals. So looking at this, I know diagonals of a rhombus bisect each other and they're also congruent, so I have 4 identical pieces. Do we all see that? But in a parallelogram, the alternate interior angles are congruent and the other set of the alternate interior angles are congruent. The common mistake I'm going to see some of you guys do on your next assessment was basically taking this image and repeating it to your parallelogram, but you can't. Only alternate interior angles are congruent in a parallelogram. Okay? Should we write that in words? Would that be helpful? Okay? So only alternate interior angles are congruent in a parallelogram. In a rhombus, it bisects them all to 4 congruent angles. So they're all 4 congruent angles. Did everyone write this down? Okay? All right, let's see if there's another page. No.